When a sperm whale calf is born, it is negatively buoyant. It has virtually no capacity to float. Without immediate physical intervention, the newborn will sink into the water column and drown. Survival requires immediate, sustained lift from the adults. They have to physically push the calf upward, keeping its blowhole above the surface so it can draw breath. Because these animals spend their lives far offshore and deep underwater, direct quantitative observation of how they coordinate in this high-stakes environment has been virtually absent from the scientific record. That changed with a group of 11 sperm whales living off the coast of Dominica, cataloged by researchers as Unit A. Unit A is a multi-level social structure made up of 2 distinct matrilines. During regular day-to-day foraging, these 2 genetic families operate as separate subgroups. They rarely associate physically at the surface. Yet, empirical data from a documented birth event shows that the delivery of a single calf triggers a rapid, transient restructuring of their society. The standard genetic barriers dissolve to keep the neonate alive. Researchers captured this birth using high-resolution aerial drone videography. The exact moment of delivery was marked by a distinct plume of blood at the surface. To translate this raw footage into data, computer vision pipelines segmented the individual whales. This image shows the exact numerical labels and colorful segmentation masks applied to each whale, allowing researchers to extract precise spatial coordinates. With the whales isolated, the algorithm extracted orientation vectors from these masks. This maps exactly where each whale is pointing, making it possible to mathematically measure directional attention. The event was then structured into 4 chronological phases: pre-birth, during birth, post-birth, and end of event. Mapping the coordinate data across this chronological timeline gives us the ability to mathematically deconstruct the unit's cooperative engine, scaling from the entire group down to individual physical interactions. We start by looking at the macro-level spatial dynamics of the group during the pre-birth and during birth phases. These charts track the unit's physical compactness over time. Panel A measures spatial cohesion. Panel C maps connected group size. The dashed line is the typical foraging baseline. Notice the massive spike into the post-birth phase, showing cohesion far above historical norms. Biologically, this means the unit completely abandons its loose foraging formations. They collapse into an unusually dense, highly synchronized cluster. We measure focus using the directed attention metric, calculating where orientation vectors point. The pink line shows collective attention tightly focused on the mother during delivery, but as delivery concludes, attention snaps. The turquoise line takes over, shifting focus sharply to the neonate. At the macro level, the entire 11-whale unit operates as a single coordinated entity. Its spatial logic is dictated entirely by the newborn's location. Moving to meso-level analysis, we investigate who interacts with whom using kinship homophily, the preference to associate strictly with genetic relatives. Normally, this is close to 1. This chart tracks kinship homophily dropping to near 0 during active birth phases. This proves the 2 distinct matrilines, purple and yellow, are perfectly integrated, abandoning genetic segregation. In the end-of-event phase, the red line spikes to 1 as families separate to resume foraging. This transient mathematical collapse of homophily proves that the immediate physical demands of a birth completely override standard kin selection barriers. Finally, we analyze micro-level dynamics, quantifying exact physical allocare applied to the negatively buoyant calf. Physical support is strictly defined, 2 segmentation masks overlapping within a tight 20-pixel threshold. This timeline in panel B tracks contact across the entire post-birth phase. There are 0 gaps in physical contact. At any given second, at least 2 or more whales are actively touching the newborn, creating built-in redundancy to prevent the calf from sinking. Panel C breaks down individual support contributions. Every single member of the unit assumes the primary support rank at least once. A core group, the mother, aunt, and juvenile, provide the vast majority of continuous contact, covering 96% of the observed time. When the core group takes a brief gap to breathe, non-kin members of the other family line systematically step in to cover the missing lift. This heat map displays point-wise mutual information, which calculates the likelihood of specific pairs acting together. The high coordination values among non-kin dyads statistically rule out random swarming. This is a highly structured, fault-tolerant turn-taking system designed to guarantee continuous support. From the macro spatial density down to the micro turn-taking matrices, The data outlines a specific biological architecture. The event functions as a singular biological mechanism reacting to extreme environmental pressure. The groups merge, execute the task, and fracture cleanly back to baseline. Without this redundant, unit-wide caregiving network, the calf simply sinks. These findings offer a specific answer for behavioral ecology regarding the evolution of sociality in marine mammals. Historically, hypotheses credited communal defense against predators as the primary driver of group living in sperm whales. This dataset proves that the extreme physical stakes of neonatal care are a primary evolutionary pressure forcing these complex social bonds to exist in the first place. This forces a reevaluation of kin selection and inclusive fitness in these populations. Quantitatively observing strict genetic barriers completely dissolving in wild, long-lived social mammals is incredibly rare. Yet this highly structured cooperation between non-kin is a structurally necessary feature of their survival mechanism. Navigating the immense physical constraints of the deep ocean requires an architecture of cooperation that transcends genetics. Sperm whale social complexity relies on the shared collective responsibility of drawing a newborn's first breath.